Jeff, we were together for the first session in which we talked, let me get hold of this correctly. I often do this blunder, so.
Okay.
We did the first part of our episode 10, and now we are on the second part, which is the effect of yield on business metrics. Right. So in the first part, we talked about the management system that you had we talked about.
Yes.
And in this part 2, let me hear from you what you have in mind with respect to effect of yield on the business metrics.
Sure.
In the first part, we did draw a pyramid. You can get that on this thing, or let me see if I can get that correctly here.
Okay.
So,
yeah, I should be sharing now. And we look, well, we got it all marked up there, Dr. M, but that's it. Yeah.
And now we go to the financial part of it, right?
Yes.
Yeah.
So really, it's just explaining this one simple little, it's a kind of a simulation. This is actually just an Excel spreadsheet that I've pasted in there, but I want to go through this and create this table right here by hand, and just contrast a business. Let's say this is a competitor of ours whose first time yield is high, 100%. And let's say for us, we only get it right 50% of the time, half the time. We only get it right half the time the first time. And then that's going to involve extra resources. Here is the process. You can see it's super simple because just easy to understand. We're going to produce a product. We inspect it, and then we ship it. But of course, when we inspect it, not all of it is correct. And so it has to go into a rework loop. All right. And I'm making some assumptions about the time. All these assumptions just make the numbers very easy to do in your head, so it's easy to follow. So I'm saying that we're producing 2 of these units per hour. So that's the rate. And this is assumed to be also 2 hours to produce a unit. And when we inspect it, these are just assumptions. It takes an hour to inspect the product or the service. And then if we do have to rework it, it takes a lot more time from the unit's perspective because it doesn't get worked on right away. It gets set aside and people will eventually get to it to rework it. So all of these numbers I have circled are built into this little matrix, really just a calculation table there. So I want to draw it by hand, and we're going to look at the effect of yield on lead time, work in process, and capacity. And there's many others, of course, but these are easy to calculate.
Jeff, although yield is a commonly used term, but then can you define yield for me? And
yeah,
because there is a confusion between waste and yield in the
there is. Okay.
in our community. There is, I mean, many of them know it. I'm not I'm not saying they don't know it, but since we are broadcasting this, I want you to make a specific definition of yield as you have projected it here.
Okay, I'll do that. And I'll just sketch a little bit here on that. So let's say this is, let's say this is inspection here. So listen, I'm going to produce something. I'm going to inspect it. So I start 10 units. This is the processing. I start 10 units. And let's say after inspection, I get 9 units come out. So in this most common definition of yield, it's just output divided by the input. And that's all we mean by yield. And we usually turn it into a percentage, something like that. So that's yield, and it's a very common way to calculate it. I'm not going to use that particular definition of yield. So I'm going to say what we had was one of these units came out, but I did rework on it. Okay. So I eventually got all 10 of them out. So I'm going to calculate the yield here. And as you can see, it's 10 over 10.
Mm.
And so percentage wise, I would say it's 100% yield. But you can see that ignores the problem that I'm producing defective product and having to rework it. So this definition of yield is something I won't use. So we're going to talk about, this is less common. We're going to talk about first time yield, which means this is the output before any kind of rework divided by the input. Okay. And in my little example.
Yeah, this is what we also know, term it as first time right.
Okay, first time right. I get that. That's the same thing.
Mm.
So in my example, I'm saying the yield, the first time yield is 90%. Sometimes we call this classic yield. There's different names for it. But the idea is yield is not simply output over input. You have to account for the rework. So that's when I'm saying yield, I'm really talking about a first time yield. Okay. Your thoughts on that, Dr. M?
That's perfect. I understand that.
Okay.
Yep.
Yeah. Okay. That's a great question. I do think yield is confusing. Well, I'll go back then. I'll get another sheet here and I will recreate what you saw in that slide and go through the calculations once.
Yeah.
Okay. So here we go. I'll use some different colors and stuff to try to make this easier to see. But here's the reproduction of what you saw. This is the rework loop. This is your output. Okay. So I'm going to create a table here, and I'm going to say in the table, I've got the first time yield. I got the time for processing. This is processing. I got the time for inspection. And I also have the time for rework. Okay. And what I want to calculate here is the lead time. I'm just going to start with that metric. So let's say this is our competitor and their first time yield is 100%. So what is their lead time? Had that phone turned off. I'm sorry. It takes them 2 hours to produce a unit. Now, they don't know if it's good or bad yet. They have to inspect it. And it takes them an hour to inspect it. Now, I just gave you those numbers. Those are assumptions. Remember, this takes 5 hours. Now, they're not producing any defects. So how much time do they spend on rework?
0.
0. So their lead time is 3 hours. Now let's look at, maybe this is us. And again, just to make the numbers easy, let's say our yield is 50%. Well, it still takes us 2 hours to produce a unit. That didn't change. But look what's going to happen when we inspect. You're going to have to inspect every unit once. But how often will you have to inspect a unit again? Well, half the time. So see, the workload has gone up for inspection, and it takes an hour each time we do it. So now to get a good unit, we're spending an hour and a half on inspection instead of an hour, okay?
Yeah.
Now the rework, we reworked it. We rework half of them, but it takes 5 hours to do it. So on average, to get a unit through rework, it takes us 2.5 hours.
Mm.
So when you add all those up, because of quality problems,
Yep.
and I'm not addressing flow, and I'm not doing that
Agreed.
right now. I'm just looking at the quality of it.
Yeah.
Our lead time is double what it could be compared to our competitor.
Yes.
Now, the implications of that are big. So I'm going to scroll up just a little bit here if I can. And just a reminder of Little's law.
Yep.
And I want to look at inventory next. So Little's law says that your work in process
Yes.
is equal to your rate times your lead time.
Yes.
And I think of that as a physical model of that is you have water flowing through a pipe. And the amount of water in that pipe depends upon the length of that pipe. So the amount of water within that pipe depends on the length of the pipe.
Yeah.
Well, the length is like lead time in a process. So if it's flowing, the longer the process, the longer the lead time, the more inventory is going to be tied up within the process. So when I go do this, I want to know about WIP now. Remember, I assumed the rate was 2. So I take the rate of 2 times the lead time. So this is 6 pieces, let's say, and this is 12. I'm taking the same rate times the respective lead times. So now we're going to look at another metric, but now what we've got is it takes us twice as long. Our lead time is twice as long.
Mm.
I'm not talking about tack time here, these things yet, just the lead time.
Yeah.
But also we have twice the inventory of our competitor. Okay. So lastly, let's look at capacity, or let's just say capacity. So when we talk about capacity, let's see. Okay. Well, it's equal to the number of good, I'm stressing good, number of good units
Yeah.
divided by some kind of time, and we're using hours, okay? So if I take the reciprocal of capacity, this is the lead time. It's the number of good units.
Correct.
Okay. But anyway, the reciprocal of that, if you look at the units, it's time. Let's see. Dr. M, let me just check something here
Yep,
real
no
quick.
problem.
Yeah. Lead time is the time. Yeah, thank you. It's the time per good unit.
So the unit of measurement for lead time is in times unit.
But I'm saying it's the time to produce a good unit,
Wow.
not just any unit, a good one. That's a distinction we're making.
Time taken
Now,
per unit of production.
yes,
Okay.
good unit.
Yeah.
Yeah.
Good unit.
On this, these are just averages. Now, if you look at capacity, it's reciprocal of that. So in other words, it's the number of good units per some time. So that is capacity. I'm just showing you in a simple
Yep.
model where it's flowing.
Yep.
Lead time and capacity are related. They're correlated. So if I go up here now and then put in capacity, well, the capacity here is 1/6. It's 1/3, the lead time. Then I'll use red down here. This was 12. And this is 1/6. Okay. 3 very simple business metrics. And we're looking at how yield, or we could say quality, but what we're looking at how yield impacts these metrics. So let's say we are this company, we're the red, and our yields are poor, but we don't have the time to fix anything. So let's think about this. We don't have time to fix this stuff. We're just going to have to go with what we have. Well, in order for us to have the same capacity as our competitor, what are we going to do? We're not going to bother to improve quality. So we kind of have to double our resources. Maybe we do a second shift or something like that.
Yeah.
Now, that's kind of expensive, but we don't have time to fix quality. So I'm being pretty hateful here.
No.
But this is showing you, we used to work with the Air Force, and they would have their shops for overhauling their engines for their fighter aircraft and whatnot. And they would usually be someone at a colonel level, and they would come to us at GE, and they wanted to be trained in Six Sigma. So the first thing I would ever do is show them this, because all of them had similar problems. They all had capacity problems. You see what I mean?
Yeah.
So I wanted them to know as early as possible, this is why you need to learn these things, okay? Because you can get your throughput up, or you can get your capacity up kind of for free in a sense, without having to invest in a lot of new equipment and things like that, if you would just go after your quality, which would mean their yields.
Yep.
Okay? And we would show them other things. But again, how do you sustain this? If even these simple little simulations like this, if they're not understood, they don't get why improving quality should be part of every business's strategy. You see, it's part of the strategic plan. It should be. It's that important. So I
Mm.
wanted to show you that. What are your comments on this?
I mean, I understand that in toto. Let me look at it from the TPM point of view, since I'm also a trained TPM.
Yeah,
We have what we calculate the overall equipment effectiveness, right?
right,
Now, I
right.
have used overall equipment effectiveness. Uh, if I increase that overall equipment effectiveness by even 10% to 15%, I am increasing the internal capacity of the organization. I don't have to buy a separate equipment. Okay.
Right.
That's anyway it is the availability into performance into quality ratio. That is how we calculate the OEE, because there are different
Yeah.
ways of doing it. In brief, this is the way we do it, and
Yeah.
invariably the quality aspect, the yield aspect, is for easier purpose they're taken as one.
Yeah.
Okay.
Yeah.
Secondly, we don't. I mean, for very often there is many products that go through the same equipment. Okay, it is not
Yes.
dedicated equipments, and each
Right.
of them have got different OEs because
Yes.
the quality is affected, and it is not one in all the cases. Okay.
Yes.
So that's my take from the TPM point of view, and which
Yes.
we don't use OEE, or I have never used the OEE to win Deming's Award, okay, by saying that
Yeah.
that if it's a process industry, it has to be greater than 95%. If it is a discrete industry, it has to be greater than 85%. That's a thumb rule.
Yeah.
And very often backward working is done. Okay, but that's not where I'm coming from. It's looking at it from the capacity point of view, that there are instances where we have improved the capacity, increased the OEE, which therefore resulted in the factory not buying an extra equipment.
Okay.
Resource,
Okay.
as you said.
That's good. I like that.
Okay.
Now, notice it. Let's look at that inspection step. So this is equipment. Let's say it's a test stand or something, but it's equipment.
Jeff,
Jeff,
since you have drawn this,
go.
I'm also flowing with your thoughts. One of the things that when we talk, I talked from the TPM point of view, let me talk from the flow point of view now.
Yeah.
Okay. So one of the things which we use, what we call the Q matrix, and I'm sure you're aware of it. And there what we say is the maximum number of control points that we can have in the process, the less number of inspection points we need at the result area. That's the dictum that we follow. We build as much control points in the process so that we don't have that many checkpoints in the result area. And that's what we follow.
Okay. I like it. I like it. When we talk about equipment effectiveness, now I know there's 3 components to that. I know that. But in this case, I would just have to see how that number is affected by the fact that I am using that inspection equipment, let's say 100% of the time. That's because 50% of the time I'm running it when I don't need to. And so I get concerned about metrics that aren't dependent, at least in part, on yield and things like that. You see what I'm saying?
Mm.
But anyway, I'd have to look at the 3 computations that go into that OEE number and see what happens when yield changes. Okay.
That's okay.
But I do know at one time in the world of lean, they weren't interested in having machines run near 100%, because they didn't need to, and things like that. Yeah. So at any rate, this is just a simple simulation describing the effect on some other business metrics.
Yep.
critical business metrics that are affected by yield, okay? And again, I don't know how finance captures these kinds of things. Finance captures these kinds of things. They reflect the end result. The finances reflect the end result, such as WIP and things like this. But this is affecting on-time delivery and all kinds of things like that you typically don't capture with finances. So anyway, an improvement of quality is almost always good and it has a important effect on the performance of a business. Okay.
And Jeff,
And to tell you the truth, if you would look at critical processes in whether it's a bank or if you look at their critical processes, most don't know what those yields are. They've never measured them. They don't know what yield means in that context and so forth. So they're kind of blind as far as their operations are concerned on how they can improve them. So I'm sorry I interrupted you.
No, we're just coming to the same thing. Touching on what you said of how the finance is capturing it. Okay, that is quite significant to me, because when we discuss the first part of the project, one of the things that we said that the gaps have to be having value in terms of the finance part of it. Okay,
right.
And if the finance doesn't capture the WIP and the capacity in the financial terms, then how do we attract the CEOs to understand that? And you are adding that in certain processes, like in service sectors and in other sectors, which unlike manufacturing, you can see it. Okay, you can see WIP on the shop floor,
right.
But
right.
in a service sector, you will not be able to see it.
Yes.
So like the call drops on your mobile or on your Zoom calls can't be seen. And that is yield loss, right?
Right.
So
that's right.
I hand it over to you. Yes, I understand that.
Well, see, for example, like a bank.
Yep.
They have a kind of inventory. So maybe there's loan applications and it's just taking them, weeks to approve a loan application. Well, that application being unapproved is costing them money. It's not money, it's not material that they've paid for, but the fact that it's staying in the system is not generating any money. So there's a kind of whip like that in the service industry as well. Just an example. Yeah.
Yep.
Okay. Well, you want to move on to the part 3, or did you have other things you'd like to say here?
No, I like this example. Like, for example, there's certain things that are not seen and is not captured in finance. And
Yes.
Our thrust right from the first part to the second part is how do we show this in terms of finances so that the CEOs get attracted to that. So that is one of the keys which we have been talking about is how do we get the CEOs attracted to the project? We have to show them in terms of dollars, as you said, and rupees, as I would like to say. Okay, so how do we get that attraction? And here you have a case where it has not been captured. Okay,
right.
And we need to capture the lead time, the capacity loss, and the finance has to, some way it has to be reflected.
Yeah.
I understand this because
well, let's say in this model, Dr. M, let's say they when they rework, there's almost never any time where the rework didn't work. In other words, when they reworked it, it really was fixed. Okay. So when you're reporting that type of yield like this, when you're using that type of yield, in the financial reports, okay, you miss the fact that all of this is happening. Okay. So this costs a lot of money, that in there, but they don't see that. So let's say the CEO comes along, and if they're using the wrong measurement of yield, the CEO says, hey, the percent scrap is 0. Therefore, there really isn't any leverage in focusing on quality and trying to improve quality. See, because the scrap rate is so low. But the reason it's so low is because it's not captured. It's not reported correctly. So that first time yield metric is often an eye opener. As honestly, the most clients I've talked with, they'll show me their scrap rate and it's around 2 or 3%. And so they think the cost of poor quality for them is only 2 or 3%. Well, that's just wrong. It's more like 15 or 20%. And if it's 15 to 20% of revenue, a CEO should care about that, but not 2%. See what I mean? So that's an ongoing problem, getting that to be recognized.
Isn't that which Six Sigma calls it the hidden factory?
Yes, it is exactly what it is. Yeah, it's real and it's costing money. It's just not captured. Yeah. Okay. All right. Well, great. Ready to move on?
So how do you sum it up, therefore, that the cost of poor quality is directly the bottom line?
Yes, the cost of poor quality is much higher than the C-suite believes it is. It's much higher, several times higher. And the attacking the cost of poor quality should be part of any business strategy.
So
that's kind of my takeaways.
What should the CEO look for? What should the shadow, as you said, of the CEO, the champion, look for and tell the CEO?
The champion needs to look at how they're measuring yields. How are they, it's a calculation really, but how are they measuring yields? Okay. And recognize that even the best companies are losing 15 to 20% of their revenue because of the cost of poor quality. So the champion has to do some things to try to uncover that. Okay. And that would mean just give a couple of examples, just some local areas, just a couple of examples of what the real losses are, not what's reported.
Okay, as a Gemba guy.
Yeah.
Jeff, a Gemba guy. Says that would mean that the champion should visit the Gemba and look around to see where the rework is happening. And I assure you, it'll be happening behind closed doors. That's what my tells me.
That's right. I mean, the champion goes to the Gemba and talks to the workers. They're the ones that deal with it. They feel it every day.
But I'm sorry again, sorry for this, because the Gemba reality is that the hidden factory is hidden. And you will never find it in the Gemba. You will find it in the salvage yard. And then that will be brought up into the warehouse. It will not take the proper route. It'll take, I'm sorry, that's what I saw in the Gemba. I don't know if it is true everywhere. I don't know whether it's universal. I just told you what I saw in the Gemba.
Yeah.
Bail me out. Bail me out.
No, in the Gemba, you don't see the hidden stuff. You're right. So all that extra labor, the constraints it puts on the system from this hidden factory that you're referring to, you don't see it. You don't even see it necessarily in the scrap yard because it's being reworked before, it's it's shipped. So it's all corrected. You don't see that. You don't even see it in the scrap. You have to find it in what's really happening in the workplace. Yep.
So that's the responsibility of the shadow, because I'm not going to use the word CEO, okay? Because
Okay.
you have already asked the CEO to delegate it to somebody who is going to look after
That's right.
his job.
That's right. Yeah. Yeah. But of course, people will be trained with the right training. There will be many people locally that will know to watch for that hidden factory and how they calculate metrics. You know, one best practice is I'm going to try to produce something that looks like a book here. Let's see.
Have you ever tried a career or a profession in art?
Absolutely not. So this
No,
is a metrics manual.
yeah,
You remember when we talked about BOPI?
yeah.
Here's an example. A common metric is defects per unit.
Mm.
With one company, they've realized that there were 6 or 7 different ways within that same company that they calculated defects per unit. Okay. So the point is, a metrics manual tells you how you're going to calculate or measure something so that there's no variation in the metrics. If you are mixing metrics, people are doing the metrics differently, you're going to lose that correlation from the process level up to the business level. So another good practice, a metrics manual.
Yeah. So therefore, this metrics manual, I'm referring to the part 1. Okay.
Yeah.
Right from the top, from the business to the operation to the process, the metrics that we said were correlated to each other has a predefined formula in which they have to be worked out. And that is non-negotiable.
Yes. Very important. Yeah. Very important.
And who is a custodian for this being non-negotiable?
Well, the champion's overseeing everything, but there'll be someone in operations, for example, that will watch over that metrics manual, maintain it. It would be a document that is, has controls on it. You can't just go in and change it unless you have the proper signatures and things like that. So, yeah, that's how it would work. Again, we're only being very high level here.
Yeah. Sounds easy stuff, isn't it? To sustain that.
The concepts are easy, and executing them is where it takes all of the skill and the leadership, frankly. It's an execution. Yeah.
That requires a lot of trust and lot of, I don't know, it requires a lot of cascading and support that is required to be transparent. And if I made a mistake, it's a mistake. If there is nothing, I mean, I'm not asking for the moon, am I? When they're saying just report what you have seen and not what your boss would like it to look like.
Right, right.
It happens in many organizations, does it? And that has to do something with the culture.
Yes.
It's all intertwined, right?
That's why Deming stress drive out fear. That's very destructive, that fear. Yep.
Thank you for.
And by the way, the metrics manual, I wouldn't expect that to be done up front. When you start experiencing these things, the need will reveal itself. And then, after some experience, you'll start creating that metrics manual. Okay.
But thanks for bringing Deming in. I'm still studying Deming, and I don't know how many times I've read it, but I'm getting in terms with it, and great. And thank you very much for this. And we have now connected the first part to the second part. Can you just sum it up for me from the first part to the second part?
Yeah, the first part, again, is about making sure projects which are necessary for improvement, project by project, making sure those projects are aligned with the business strategy, but aligned by metrics. Okay, just not by the idea that this ought to make a difference. We want to align them by metrics. And this second part is incentive for CEOs to adopt a quality improvement strategy, for example, which is what that BOPI is about. That's the management system as far as the metrics. So this is just one example to help the C-suite recognize the value of improving quality. What's the impact on high-level business metrics as you improve your quality? And so this is tied in with the BOPI. I mean, you improve quality, it flows up to the business strategy.
And this keeps the interest of the CEO glued on, right?
Yeah, that's right. That's right.
Thanks a lot.
One incentive.
Yep. Sure. Yeah. Go ahead.
And we have some more to show.
Okay, so this looks great. And should we move out now? I start recording this and move on to the third part that we are coming to.
Yes.
Thank you very much for this. I understand
Thank you
very well, and I understand capacity, and I understand the significance of converting that into rupees, dollars, and attracting the top management to take a look at this matrix. And one of the examples which you gave was of quality.
Yes.
Thanks a lot.
Yeah.